So let's do number 19 from number 19 onward, okay? So this is college Panda test 1. So for number 19, so square root of x plus square root of y is 4 times square root of y, okay. So we can subtract square root of y from both sides. So we're gonna get a relationship directly between the square root of x and the square root of y. So minus square root of y here. So this side going to become 3 square root of y, because so now square root of x equal to 3 times square root of y. No more addition needed. So we're gonna square up both sides. We're gonna square up both sides and see. So square equal to this side square. So sorry. So this side square. So this side square root of x squared is x, and square root of 3 times square root of 9 squared is actually 9y. So yeah, so it's B. Okay, so this is very simple and very understandable, right? Number 20. Richard has 7 times as many pineapple as Fred. Nathan has 3 times as many pineapple as Fred. Okay. Richard has 32 more pineapples than Nathan. How many pineapples does Fred have? So Richard is 7 times as many, has 7 times as many pineapples as Fred. So R equal to 7F. Okay. Nathan has 3 times as many pineapple as Fred, so N equal to 3F. And Richard has 32 more pineapple than Nathan. Richard has 32 more pineapple than Nathan, so R minus N is equal to 32. Alright, so so here we have R is 7F and N is 3F, so 7F minus 3F equal to 32. So 4F equal to 32 and F equal to 8, right? So the answer for 20 is B. Alright, and 19B and 20 is also B, so that's valid, and it's also B. Alright, let's keep going. Number 21. Okay. So during a high school basketball game, Michelle scored 30 times for a total of 60 points. If he ends the game with X 2-pointer and Y 3-pointer, so he actually scored 30 times, right? So X plus Y has equal to 30, right? So X is 2-pointer, so 2X plus Y is 3-pointer, so 3Y equal to 68, and that is corresponding to the system number A, right? That's corresponding to system number A. 21 is A, and indeed 21 is A. Alright, let's do 22 and 26. Okay, right. So 22. Given the right angle ABC above, which of the following is equal to C over B? Okay. So 22. So we know that C over B for tan of C, but here they want us to give it to the angle B, right? The angle B, to the corner B, right? To the angle B. We want to make the relation between this ratio and the angle B. So this is actually the adjacent, right? adjacent over the opposite, right? So C over B is so that's actually the cotan. That's actually the cotan of B. So that's actually 1 over tan B. So that's actually B. Yeah, it's a fucking B again. What the hell? This is B. Adjacent over opposite, so it's the reciprocal of B of tan B. Reciprocal of tan B. So it's 1 over tan B. Alright. It's B. So alright. 23. Okay, so it's a low lighting effect versus reading speed. Okay, to determine the with the low lighting effect's reading speed, a researcher randomly selected 30 subjects to participate in the study. Half the subjects were randomly assigned to read an article on the low lighting 400 lumens, while the other half read the same article on the normal lighting 900 lumens. So it's talking about the intensity of the light. The resulting data show that the subjects who read the article on the low lighting took significantly longer than those who read the article on the normal lighting. Alright, based on the design and the result of the study, which of these following is an appropriate conclusion? Low lighting is harmful to light. So this experiment actually have nothing to do with the effect on the eye, so A is wrong. This is not A, okay? Everyone reads slower on the low lighting. Alright, this seem pretty good, but there's no evidence that this is 100%. There's no evidence that this is 100% because they just took significantly longer. But not everyone is lower. You know, the resulting data show that the subjects who read the article on the low lighting took significantly longer. That's not all of them, okay? Not everyone. So I don't think B is correct either. So C and D is left. Low lighting is likely to cause a decrease in reading speed. This is possibly highlighting about 1200 lumens is likely to cause an increase in reading speed. Again, there's no experiment with 1200 lumens. So I think the answer is C, right? Because that's the most likely is C. And it's indeed C. It's indeed C, because AB is not relevant, whereas D we have no experiment to support that. Meanwhile, in C there's a actual result that actually imply answer C. That low lighting is likely to cause a decrease in reading speed. Because 400 lumens lighting read significantly longer than those who read under 900 lumens lighting. Alright. Let's move on to number 25. Oh, we have 24. Where's 24? Okay, here. A train traveling at a rate speed of 80 miles per hour take 8 hours to complete a given trip. Alright. That's nice. How much time will it take the train to complete the same trip if it traveled at a rate speed of 120 miles per hour? Okay, so we can find out the trip length. The trip length is just gonna be velocity times time. Just a velocity times. So that's 80 miles time hour to the minus 1 over hour time 8 hour. So that's the 640 miles. So now time 2 it's just length over velocity 2. So that's length is 640 mile over velocity 2. So it's 120 miles per hour. Mile per hour. So I think that's roughly 5 more than 5. 5 and 40 divide 5 in the third, so it's 5 and 5 hour and 1/3 hour. So that's actually, I think it's C. I think it is C. Because 40 is just 1/3 of 120, so I think 24 is C. 24 is C instead. So indeed, so it's C. Also 25 and 26. Okay, so let's do number 25 and both. So okay, so we are given the formula for the kinetic energy of an object, right? So let's write it down. So the kinetic energy, the Ke of an object, is half of its velocity, half of its mass times velocity squared. So Ke equal to a half mass times velocity squared. Alright. So if the kinetic energy of a moving tennis ball is double, what its velocity must have increased by what factor? Okay, so so 25 we have Ke1. Okay, so it's just keep it normal, because here we're gonna keep m constant, because the mass doesn't change, and we have Ke2. The equation for the velocity 2 is also 1/2 of this, but with the velocity 2 squared. Okay, so they say that the kinetic energy of a moving tennis ball is double, which means that Ke2 is equal to 2 times Ke1. So the kinetic energy of a moving tennis ball is double. Okay, so Ke2 has to be 2 times Ke1. So we're gonna substitute the equation in. So 1/2 of m v2 equal to 2 times 1/2 of m v1 squared. Okay. Alright, so here we have 1/2 and m on both sides, so we're gonna cancel it. So we have v2 squared actually equal to 2 times v1 squared. Okay, so actually v1 v2 gonna be square root of 2 times v1, because we take the square root of both sides. So it's D, right? It's D. Alright. Number 26. the radioactive element lost 15% of its mass and 20% of its velocity. By what percent has its kinetic energy decreased? Okay, so the original key E, I'm gonna say key EO, is gonna be still 1/2 of mv squared. So let's just get rid of u1 and just put v. Okay, so key new. Okay, so key new. So it's 1/2. Okay, so the radioactive element has lost 15% of its mass, so only 85% of it left. So it's 0.85 m, right? And 20% of velocity, so only 80% of it, 0.8 v, and this is square. Okay, so this actually 1/2. We're gonna keep it constant. We're gonna still keep m times v squared, and this has to multiply by the factor of 0.85 times 0.8 times 0.8. So we're gonna convert this factor to percentage. Okay, this factor to percentage, because this is actually KEO. So this is actually KEO, right? So time. Okay, so let's calculate this factor. Is 0.54, 0.544. So loss percent is equal to 1 minus 0.544, which is 0.456. So that's equal to 45.6%. So the answer should be D. So it's so 25 and 26 OD. So 25 and 26 OD, and is indeed 25D and 26 also D. Alright. Let's try number 7, 28, 27 and 28. So 27. Alright, so they give in the rectangle, and we give in the figure. So I is trisected. Alright. So what's the length of BF? Alright. So let's actually draw this figure out. So we have a rectangle. Nicely this. Okay, so we're gonna trisect the angle A. Okay, so each of these is actually 30 degree. Just still do, you know, like this and that, but each of these is actually 30 degree. Okay, so this is actually A, B, C, and D. A, B, C, and D. Alright, so this is E, this is f. Alright, so we know that fc this is 1. Alright, and we know de is 6. Alright, and we know that this is 30 degree. This is also 30 degree, and this is also 30 degree. Alright, it's trisected. The angle A is trisected. Okay. What is the length of BF? Okay, BF. Alright. Okay, so now we know that BF is equal to BC minus FC, which is BC minus 1. So in order to find BF, we have to find BC, right? So the seventh. But in the other hand, we also know that BC is equal to AD, right? So AD, so triangle ADE, at the angle ADE, the D angle is 30 degree. So AD gonna be equal to DE times cotangent of 30 degree, right? So it's cotangent of 30 degree. So let's search cotangent of 30 degree. That's actually on 1.77. What the hell is that? So that's actually square root of 3, right? That's actually square root of 3. Cotangent of 30 degree is actually square root of 3. So that's actually BC is actually DE is 6 times square root of 3. Okay. Okay, so actually BF gonna be equal to BC minus 1, gonna be 6 square root of 3 minus 1. Minus 1. So the answer is D. Alright. So it's D instead. Okay. Alright. Okay, 29. Okay, let's solve the system of equations. So 28, we have x minus 3y equal to 4, and 2 times x minus 1 minus 6 times y plus 2 is equal to negative 6. Alright, so this is the second equation is 2x minus 2 minus 6y minus 12 equal to negative 6. Alright, so 2x minus 6y equal to negative 6 plus 12 plus 2, which is 8. So this is actually 2 times x minus 3y, and in this side 2 times 4. So So it's actually you take all of the first equation multiply by 2, right? So this system of equation actually just one equation, yeah, just one equation, it's just equation 1. So it has infinitely many solutions. So the answer is D, more than 2. Okay, so it's D, more than 2. Okay, so there was actually a check for this kind of equation. So if equation 1 is A1 x plus B1y equal to C1, and number 2 is A2x plus B2y equal to C2. So if A1 over A2 equal to B1 over B2 over B2 equal to C1 over EC2, and this system has infinitely many solutions. Alright. So but if A1 equal to A2 and B1 A1 over A2 equal to B1 over B2, this is different from C1 over C2, then this system of equation has no solution at all. No solution. And in the case of the first equality is not satisfied, so it usually this system has one solution. Unless there are some some extreme cases. So that's the equations. So if the ratio are all the same, we have infinitely many solutions. If only one ratio be satisfied, equal to the other, equal to another ratio, then we have no solution at all. And if the two coefficient of x and y are actually different, usually we have one solution. That's what usually is. Alright. Okay, so that's number 29 and 30. It's almost the end of the test. Only a few left, right? So for number 29, we have the f observed. So f of observed is equal to fs times v of w over that's look like a funny face, right? Over v of w minus v of a. Okay, alright, so that's the ambulance moving velocity in meters per second toward the observer standing still on the sidewalk. Because this movement, actual frequency of the sound emitted by ambulance fs in hertz is perceived by the observer to be different frequency f ops. Okay, so the frequency is different due to observer. Okay, the siren sounds wave travel at velocity of vw in meter per second. The formula, okay, so vi is the moving speed of the ambulance in meter per second. The formula will show the relationship between those variables. So now the answer is what is vi. Okay, so all right, So now we have to find VA, right? So now we have that so M observed is actually MS times VW over VW minus VA, because we just multiply MS in, right? So we're gonna try to extract VA out. So to this point, VW minus VA equal to F observed divided by no, this actually okay. So we're gonna multiply it. So if we multiply VW minus VA with F observed, we're gonna get MS time VW, like that. Alright, so MS, now we need to find VA, right? So so VW minus VA equal to MS times VW divided by F observes. Alright, so now we're gonna move things, changing on the other side a little bit. So we just will twist it a little bit. So VA now is equal to, so we put VA on one side and everything else on one side. So this is actually equal to VA. We're going to put VA on the other side. So we can actually simplify this. So this actually gonna be equal to F observed times VW over F observed. Okay, so minus this term Fs times VW over F observed, right? Because F observed divided by F observed is just one, right? Is equal to VA. Right? So now we have all of them divided by F observed, so we can factor out 1 over F observed, right? So it's just over F observed, and this is F observed times VW minus Fs times VW all divided by F observed, and that's actually VA. So this actually equation number D, right? Number D, equation D, right? So 29 is actually D. So please take a moment to look at this again, and please try to understand the argument. On this side, I just try to multiply everything and try to factor to multiply Fs with VW, and then on this side I multiply the denominator VW minus VA with F observed to cancel the denominator on the on the right side, and then I just give us some expansions. I just give it some expansions. Yeah. So 29 should be D. And 29 is D indeed. Alright. Let's do number 30. The velocity of Syrian sound wave is 340 meters per second. The velocity of the ambulance is 22 meters per second. And the observer perceived the frequency of 500 Hertz, which are following is actually closest to actual frequency of the siren in the sound wave. Okay, so we have to use this formula D here. So 29, 30. So we have VW, right? VW gonna be 340. VA is actually 22, and we have that F of observer gonna be 500, right? 500 Hertz, so it's just 500. So now they asked about the actual frequency of the sound wave. So Fs, they asked about Fs, knowing VW, VA, and F of observer, right? So Fs gonna be actually equal to F observer time VW minus VA and over VW. Because you can deduce this from the equation above, which is easily. So that's it. That is 500 times 340 minus 22, and all divided by 340. That's gonna be equal to 467, so 468, around 468, around that. So it's A, 30 is A, okay, and 30 is A indeed. Yes, alright, 30, 8 to go, man. Alright. Alright, so let's finish let's ask the last 8 questions, okay? Last 8 questions. Okay. So that's for number 3, 29, 30. That's 29 and 30. So there are 39 and 30. Okay, which you need to. Let's move on to 31. Okay, so let's move on to 31. Alright. So 31. Gracie regularly bought by 6 different items at the grocery store. Okay. The average price of the item is $30. Price of 5 items are 7, 25, 36, 40, and 44. Wait, what is the price of 6 items? Okay, so this one is easy. So, the number 31, the average, IVG gonna be of price 1 plus price 2 plus price 3 plus price 4 plus price 5 plus price 6 all divided by 6. Okay, so the average is 30. So that's, and we put in the price number. Price 1 is 7 plus 25 plus 36 plus 40 and plus 44 and plus P6. So over 6, so I gonna times 6 here. So okay, we'll put this over 6 here. So we're gonna multiply by 6 on both sides. So only the sum is left. Alright, so let's calculate this sum. So this sum is actually equal to 150, 52, so 180 equal to 152 plus P6. So P6 is equal to 28. Okay. So and for that number 31, the answer is 28. Okay. Alright. 32. Okay, so 3x plus 2y whole square and equal to 3x squared. 3x whole square plus 2 times 3x times 2y plus 2y squared. So that is 9x squared plus 12xi and plus 4y squared. Y squared, right? So that's very clear. So that's a squared plus ax squared plus bxi and plus cy squared, right? So we know that a equal to 9, a equal to 9, b equal to 12, and c equal to 4. So a plus b plus c should be equal to 25. Alright? Alright. Very nice. Very nice. Okay. So it's 25 indeed. 33. Okay. So which impossible value of x that she is undefined? So 33. So gx. Oh. Alright. Just a little bit. Delete it. G of x gonna be equal to square root of x minus 1 and x minus 2 times each other. So the condition, okay, the condition for the square root to be meaningful is that whatever under the square root has to be bigger or equal to 0. Okay, so it's bigger or equal to 0. Okay, so now we can create a table of psi to okay, so they asked about one possible value for this, for gx to be undefined. So gx is undefined if and only if this condition is violated, right? When the condition is violated, which means this going to be a smaller sign. So let's make a table of psi so we can evaluate this product. Okay, so let's say a table like this. So this is x. This one. Alright. So this is x. X. Okay. So this is could be 1 and this could be 2. Okay. Alright. And now on the second line we will consider the psi of x minus 1 of x minus 1 here. And on the second line we can consider the psi of x minus 2 here. Alright. So for this we can actually consider the product. The last line we consider the product. So x minus 1, x minus 2. Okay, so when x is equal to 1, x minus 1 is equal to 0, right? Whenever x is smaller than 1, x minus 1 is negative. When x is smaller than 1, x minus 1 is negative, so it's negative here, right? Okay, so I'm gonna put the negative side a little bit more clear. So it's negative, right? So and when x is bigger than 1, wherever it is, x minus 1 is positive, right? So positive there. And a 2, I don't want to calculate this, so I'm going to give it a dash, and because it's irrelevant, it's just positive anyway. This is plus here. Okay, so same thing down here with x minus 2. When x is smaller than 2, everything is negative, and when x equal to 2, everything is 0, right? It is 0, right? So it's negative here because it is actually smaller than 2. And this here I want to calculate as x equal to 1 because it's irrelevant, right? And this is negative. So so when x is actually bigger than 2, then it's positive here, right? Okay, so okay, so let's calculate it. I want to erase this. Okay, so now x minus 1 and x minus 2. Okay, so in the range of x, okay, so let's calculate at the point x equal to 1. So x equal to 1 and this product is actually 0. But when x is less than 1, x minus 1 is negative and x minus 2 is also negative. So the product has to be positive. Alright. Alright. So similarly, in the range between 1 and 2, x minus 1 is positive, but x minus 1 is negative. So the product has to be negative. And here is equal to 0, and x equal to 2. And when x bigger than 2, everything is positive, so product has to be positive as well, right? So they ask about the value where the function is actually undefined. It's actually undefined when the product is less than 0, so it is this range, right? It is this range, right? This part, right? So it is this range, right? So anything between 1 and 2 is actually make this thing undefined. So this is equivalent with x 1 smaller than x smaller than 2. So we can give it the answer of 3/2 is quite a valid answer because it's the midpoint of the range, right? You can give the answer of 3/2, and the answer is it's between 1 and 2. So 1 and 2. So you can give 3/2 or something. Okay, because we just give it one possible value. So let's just say they give it so 33. Yeah, so just between 1 and 2. Yeah. Alright, so just give 3/2 in your gradient, and it's going to be fine. Yeah. Alright, so 33. Okay, so good so far, huh? 33 is done. Let's move on to 34. So this screenshot can take a capture of it. Okay, 34. Okay, so 34. So 8 hours, geez, for 8 hours. Is enough for 2 pizza. Okay, so 16 ounces in the pound. So 16 ounces is 1 pound. 1 pound. Whatever equivalent to well is 4/3, right? 4/3 pizza. Because just double it, right? Because 16 is 2 times 8, right? So we multiply both sides by 2. Okay, so now they set to 12 pounds, right? 12 pounds, 12 ounces, 12 pounds. 12 pounds, yeah, 12 pounds. 12, that's 1 pound, right? So 12 pounds will just be equivalent to 12 times 34/3 pizza. That is equal to 16 pizza. So this is 16. So 34 is 16 needed. Okay, it's 16 needed. These pizzas. It's 16 needed. Okay. Right, 35. Okay, so for this line you have to actually write out the system of equation. You have to read out the system of line equation. You have to draw it out. Cannot do it, like quickly. So 35, new file. Okay, so with 35 you have to know which line it is. So y minus 3x is smaller than or equal to negative 10, which is the original line, is y equal to 3x minus 10. Okay, and so our original equation is y smaller than 3x minus 10. So the original line is y equal to 3x minus 10 like this. So that's the first line, and the second line it is y plus 2x is bigger or equal to 45. So in general, y smaller bigger than equal to minus 2x plus 45. So the line is y equal to minus 2x plus 45. Okay. Now I'm gonna want to draw this out, and I want to see the solution set. Alright. So let's draw it out. So let's go to Wolfram Alpha. And let's draw it out. So y equal to 3x minus 10 and y equal to minus 2x plus 45. Alright. So far here. So this actually the picture of the two intersecting line. So let's crop it in. Yeah. I save this one a little bit. So I save it all up so we can reuse it. Alright. So the answer is to be y has to be less than 3x minus 10, right? So we have to take under the graph. Okay, so let's try to color code that. So it's a brush here. It's a blue. So I'm going to just do the line. So we have to take it under this graph. Alright. So this is the solution. Alright, so everything under this graph. And it's bigger than minus 2x plus 45, so it's here. So the solution set is actually this region. It's the intersection of a red region and the green and the blue region, which is this purple region here. So this is the solution. It's the purple region here. So they ask what is the minimum possible value of h. So it's the x coordinate. So x is smallest is here, right, at the intersection of these two lines. So it's 11, right, because we have a solution here, x equal to 11. So and the minimum of the x value of this solution set is actually right here, this point. It's the intersection point, right? So this is the intersection point. So yeah, I just got it, right? Like I got it. So this point is actually the point we have to consider, because the smallest value of h is actually the x of this intersection point. So this is actually it, like this, right? And our answer is here, actually 11. Okay, so actually you can just just put the equation in and you get it going. So number for 35 is 11, okay, because you have seen there. So I want to check if it's really 11. It is 11, okay, it is 11. All right, so 35 is 11, okay. All right. Okay, let's do 36, 37, and 38, and I think that's done for the test. All right. Okay, cocenter A handle 20% fewer code than cocenter B. Cocenter B handle 20% fewer code than cocenter C. If cocenter A handle 1200 codes, okay, so 26, A is 100, so B is 120 plus 20% of A. Okay, so that's just 1.2A, which is 1,440, right? And C is just 220% of B, right? 220% of B, so that's just 1.2B. So that's it. 1,440 times 1.2, which is 1,728. So the answer is 1728. So it's almost the taxi cab number, right? 1729. In this case, is 100,728. Okay, yeah. So we are wrong. Okay, center A handle 20% fewer code than center B. Okay, there's something wrong here. Fewer codes than center B. So B is so it's 20% of B. Yes, okay, I understand it now. So that is actually 0.8%, 80% of B, right? B. Alright. So we have to calculate according to center B for center A, right? So B gonna equal to 1200 divided by 80 times 100. That is 1500 course, right? So this is not correct, okay? Okay, so yes, and C, center B handle 20% fewer. So C is B is actually B is actually 80% of C. So C gonna equal to 1500 divided by 80 times 100, and that's gonna give us what number? So same thing here. 1875. So 1875. So that's what is C. So 1875. Okay, so I got this one wrong. Sorry, well, it's just a little bit mistake. Okay, let's try 38 and 7 and 38, 37 and 38. Yeah, there will be a lag at the end of the lesson. Okay, so 37. Male crickets vary their chirps rate according to the temperature. Alright, so alright, so the scatter plot below show the relationship between chirp rate and temperature for night crickets. The line of breastfeed is also shown. Okay, so so you know, it's like they're gonna try to plot the temperature versus the chirp per second, the chirp rate in male cricket. So for example, with the temperature of 75 degree Fahrenheit, we now have chirp rate of 16 per second. With the temperature of 87 Fahrenheit, and the chirp rate is 20 per second, or the temperature 82 Fahrenheit, 17 chirps per second. Alright, so number 37. Based on the lines of breastfeed, what is predicted the male cricket chirp at the temperature of 80 degrees Fahrenheit? Okay, so for this predicted question, alright, so so for the predicted question like this, what you want to do is that you just take point X. Well, that's the input data that they're asking. This one is actually 80, and you just put line up to the line, the breastfeed line, and you find the corresponding Y. So in this case it is actually 17. So in this case this is actually predicted as the 80 degrees, so it's actually 17. So 37 is actually 17. So that's easily understood, right? What is the chirp rate of the male cricket represent the data point? That's the farthest from the line of best fit. What is chirp rate of the male cricket represented by the data point that's farthest from the lines of best fit? So I think they are talking about this point. So the chirp rate is actually 20, right? So 38 is 20, right? So 38 is just 20. So let's check if we are correct. So it's 17 and 20. 17, 37, 20, 17, and 38, 20. Okay. I think that's the end of the test. Ooh, long test. So it's very good, right? Very good time. So thank you very much for listening. Any extra question, comment in the comment section down below. I'm gonna be happily explain it for you. So take a rest, have a cup of water. Has been a good, amazing class. Thank you very much. See you in the next video. Okay? Yeah. Thank you very much. Goodbye. Thank you very much. Goodbye. Yeah. See you later.